I did the A part in my previous video. Here we are going to do the B part. In the B part, the question is asking if vsig is disconnected from node X and okay, disconnected from node X. Node X is grounded and node Y is disconnected from the ground and connected to vsig. Find the new expression for vc over vsig. Okay, so currently we have vsig right here, and this emitter current, like at the end emitter, is grounded. So what they're saying is, now remove this vsig and ground it here and connect the vsig over here and see what we are getting, and then derive the expression for vc over vsig. Now let's do that. So in order to do that, we had to redraw this circuit, but this is the circuit I designed earlier for this one. This is the equivalent hybrid pi model. I can copy this. Oh my god. I'm gonna copy this once again. Okay, I go to a new page. I'm gonna paste it here. Now let's do the adjustment. So what they're saying is, remove this vsig and connect it to the ground. So I'm going to remove this vsig right here and then connect this one to the ground and attach the vsig over here, because if you notice, this is the X and this one is a Y. So we are removing node X and connecting to the ground. We are adding the vsig at the node Y, that is over here. So that is coming after resistor. Okay, so this is going to be now added with the voltage source. Now to illustrate the change, I'm just going to use a different color. Currently I think yellow. Yeah, let's keep it as yellow. And here we will have plus, minus, and this one is vsig. Okay, so now we have to derive the expressions. If you watch my previous video, you see how did we derive the expression. We look at this circuit like where it's flowing. If the voltage source is here, we assume the direction to be clockwise, because it's starting from here and goes to here. Okay, so this current we take to be positive, and the counterclockwise we take it to be negative. So we got the expression for this VC as negative ICRC, because this current IC current is in the counterclockwise direction. So we took it as negative IC, and IB to be positive because it's in the clockwise. But if I change the source to be here, then now this is going to be in this side, because source is here. We have to look at the current from this side to here. So it means now all the positive term we assumed before is going to be negative right now. So if we derive the expression, first if we write the expression for VC, that remains the same. VC is equal to IC times RC, and IC is as we assume that is counterclockwise, so it's going to be negative IC times RC. And now if I apply KVL in this loop, now I'm taking the opposite direction of it. Let me erase this. I don't know, I think I cannot erase it. Okay, let's just to have to know that is opposite direction. Okay, so if we do that, then the equation we already derived. If you see, this is the equation. vsig is equal to IB times RB plus R5 plus IE times RE. If I express the one in the diagram, that is, this vsig should be, if it's positive, all the other voltage is negative, and that's equal to 0. Okay, so here vsig minus IBRB minus this current, there's a R pi resistant here, that is visual in the hybrid pi model, but in the BJT you cannot see it directly. So if you put the equivalent hybrid pi model, you see the R5 resistant. That is basically right here at the emitter over here. So this IB current flow through, there's a voltage drop IBR5, and after that this emitter current goes through this RE resistance. That's the voltage drop IERE. All together forms V6. So V6 minus all this should be equal to 0. So therefore we can say V6 is equal to IBRB this times this IB times R5 plus IE times RE is equal to RE. Okay, that's the expression we have right here. V6 is equal to IB, and we combined. Here's the expression: IBRB, IBR5, IERE. Since IB is common for both of them, we took it common. That is IB times RB plus R5 plus IERE. Now for this one, since we are taking the opposite direction, it's going to be exactly the same, but we have to just put a negative in front. So if you put a negative in front, vsig is going to be, if I put a negative, and I can express the exact same term because only the direction is changing. Other than that, the voltage drop is exactly the same. So IB RB plus R5, RB plus R5, and RB is capital B, so let's keep it as it is. So capital B right here, R5, and then here we have IERE as well, plus IE times RE. RE is capital RE, and all together it should be negative. That's the only difference. Now we can just put it in the equation. We want to express the VC over VSig. So VC over VSig, that's going to be negative ICRC over this whole term, negative IB times RB plus R5 plus IE times RE. Okay, and in order to simplify this expression, we can express everything in terms of IB. IC is equal to beta times IB. Here also, if you see in the circuit model, we replace the current. This is collector and this one is emitter. Collector to emitter, we have collector current, that's IC. But we replace that one with beta IB because IC is equal to beta IB. So here, instead of IC, you can also replace that one with beta IB as well. Beta IB right here times RC, and then minus. We can cancel the minus right away because since we have minus top and minus bottom, we can cancel it right away. So in the bottom, we will just end up having IB times RB plus RB plus R5, and instead of IE, you know, in the BJT, all the currents can be expressed in terms of other currents, and if we want to express IC in terms of IB, we can express it as beta times IB. If you want to express IE in terms of base current, then we can express this one as 1 plus beta times IB as well. So this IE we can express one in terms of base current, that is 1 plus beta times IB. So times RE. And if you notice, we have IB in the numerator, denominator, we can cancel all of them. So we will finally end up getting the simplified expression for this, that is this one, beta times RC. So we are deriving the expression for the vsig over, is it VC over vsig? Yeah, VC over vsig. We want a simplified term, that's why we are bringing all the current to the same terminal, like we are bringing all the current in terms of IB, so we can cancel something and make it simpler. So here this is beta times RC, beta times RC over RB plus R5 plus 1 plus beta times RE. Okay, and that's our final expression. This is the expression for the VC over VSig. If we replace this VSig currents, which is actually voltage source, in the Y naught, and if we ground the X naught. Okay, this is what happened. The sign will be changing and we will get the different expression. And that's basically it. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.